This tutorial is going to go over the basics of multiple regression. Regression is potentially a very complicated topic, but it can also be used in a very simple way to see how well a set of predictors fit a model and allow us to predict an outcome. In this datasheet, we are going to use three variables and see to what extent they let us predict exam performance. As you can see, we have three predictors, which are all measured out of 5. The first is lecture attendance score. This indicates to what extent a participant attended all their lectures. A score of 5 means that they attended all the lectures, and a score of 0 means they didn't attend any. The second variable is participants' motivation. Again, a score of 5 indicates that they're incredibly motivated, the most motivated they could be to do well, and a score of 1 indicates that they're not motivated at all. The third predictor is assignment effort. This indicates how much work the lecturing staff think that participant put into their assignment. A score of 5 means they put in as much effort as they possibly could, and a score of 0 means that they didn't put in any. What we want to know is, to what extent do these three variables let us predict someone's exam performance? If they score 5 in all of these, does that mean that they'll do very well in their exam? Or is one factor more important than another? Regression analysis lets us see which of these factors, if any, are good at predicting exam performance and which are not very good. Of course, research examining exam performance could potentially include an enormous amount of variables, certainly much more than 3. We might also want to look at how the variables interact and how one influences another. But to keep things simple, we're just going to look at these 3 variables and how they directly influence exam performance. To get started, go up to Analyze, Regression and Linear, as we're going to be performing multiple linear regression. Put the outcome variable, the thing you're interested in predicting, in the dependent box. In this case, it's exam performance, because we want to see how well we can predict someone's exam performance based on how many lectures they attended, how motivated they are, and how much effort they put into their work score. So, exam performance goes in the dependent box. Then, we put our 3 predictors in the independence box. There are a variety of other options that we could choose, but again we're just keeping it simple this time, so that's all we need to do. We then click OK, and this produces some output. Let's now go through this output and see how we might interpret this regression analysis. The first box at the top, labelled variables entered/removed, just shows us what's gone into this regression analysis. If you use a more complex form of regression, this might be much more detailed, but for now we don't really need to look at it. The next box down, Model Summary, gives us an overall view of our regression model and tells us some of the key descriptives that we need to know. The R² box is the variable that you're usually most interested in here. This indicates the amount of variance explained by your model. It's given as a percentage, so in this case it would be 17.9%, or rounding up to 18%. I won't get into detail about exactly what that means in this tutorial, but the short answer is, the higher that the R² value is, the better. The closer it is to 1, the more accurate and predictive your model is. The next box down, the ANOVA box, gives us an overall view of our model. As you can see, the F value is 16.87 and the P value is considerably less than 0.05. In fact, it's even less than 0.01, which indicates a highly significant model. This means that, in general, we have a good set of predictors which are giving a decent chance of guessing what the exam performance of someone will be if we measure those 3 variables. The next box down, however, gives us a breakdown of our predictors and shows which individual ones are good and which are not so good at predicting exam performance. Look now at the coefficients box. You can see our 3 predictors are listed there: lecture attendance score, intrinsic motivation to succeed, and effort put into the work score. If you look on the left, you'll see the t-test statistic for each one of these and the p-value for each one. This lets us see which of these predictors actually contribute something to the model and which really don't. The lecture attendance score has a t-test statistic of 3.91 and a p-value that is less than 0.05. This means that it is significantly contributing to the model. It is adding to the predictive value of a model and lets us better predict someone's exam performance. intrinsic motivation to succeed is similar. It has a t-value of 3.61 and a p-value of less than 0.05. Again, this is contributing to the model and increasing the predictive ability of our model to work out what someone's exam performance will be. Look, though, at effort put into work. The t-statistic here is 0.42 and the p-value is greater than 0.05. This means that it is not a significant predictor. It is not adding anything to the model and doesn't actually give us any more predictive utility in working out what someone's exam performance will be. So overall, the ANOVA shows us that our model is good, and then the breakdown of the coefficients in the lower box shows us which one of our predictors, or which ones of our predictors, are actually doing anything and causing this model to be good or bad. In this case, our lecture attendance score and our intrinsic motivation to succeed are very good predictors and worth measuring, but our effort put into work score doesn't seem to be doing anything, and it doesn't increase the predictive utility of the model. Why might this be useful? Well, we could potentially have an infinite number of predictors, and some of them may be very time-consuming to measure. If it would take a lot of time and resources to measure a predictor, but it isn't really adding anything to our model, then we could leave it out, and it wouldn't be worth looking at. It's also useful if we want to create an intervention for something. For example, lecture attendance score is greatly contributing to our model and seems to be influencing exam performance. So, if the university was interested in increasing exam performance, we would have to work hard to make sure that students attend their lectures. Similarly, an intrinsic motivation to succeed seems to be doing something to exam performance too. So, we would implement some kind of intervention to try and increase motivation in students. But the effort that students put into their assignment doesn't seem to be doing anything. So, the university wouldn't need to put in any resources to trying to get students to increase their effort, because that doesn't seem to have any bearing on exam performance. Please note, of course, this data is hypothetical, and that you should put in lots of effort when it comes to filling out your assignments, just as you should to attending lectures and being motivated to succeed. One final thing to look at is in the coefficients box at the bottom of the output. If you look in the section marked Unstandardized Coefficients, there is a column marked B. These figures indicate the type of relationship between the predictor and the outcome variable. As a rule of thumb, if there is no sign in front of the figure, then there is a positive relationship or a positive correlation. So for example here, the B value for lecture attendance score is 0.19. This would mean that as the lecture attendance score goes up, so exam performance goes up. Similarly, there is no sign in front of 0.26. This means it's a positive relationship again. As intrinsic motivation to succeed goes up, so does exam performance. If there was a minus sign in front of these B values, this would mean there was a negative relationship, a negative correlation, such that as these predictor scores went up, exam performance would go down. This, of course, is vital when trying to discern how best to intervene in these predictors to maximise exam performance. This concludes the regression tutorial. We have not covered in this video what all of these figures mean, as it would simply take too much time. However, hopefully this has given you a brief overview of what to look at in your regression analyses output, so you can get an idea of what is going on in your study. For further information on what the figures in this output means, speak to your supervisor or consult a statistics book.